Introducing Tic-Tac-Toe Bot. Using the Dobot magician equipped with a suction cup, we have created a robot that will play against you in tic-tac-toe. We have modeled the robot in MATLAB and are controlling it using a Raspberry Pi running ROS. There is a graphical user interface for easy interaction with the system.
A webcam is used to detect when you finish a turn and where you've placed your tile. This is done as the positions of the board and camera are fixed, so the 3D coordinates of the spaces on the board can be transformed to 2D points on the camera's image. An area on each of the spaces of the board is sampled, and its color is then matched to the red tile, blue tile, or the background color of the board. From this, the position you've placed your tile is found. The camera detects whether your hand is in the frame by binarizing the image, then computing the sum of the image and checking whether it is significantly different to a reference image with no obstructions. As tiles move around during the game but do not enter or exit the field of view of the camera, this sum should remain similar throughout the game. However, when there is a hand or other obstruction in the frame of the camera, this sum changes and the system is alerted to an obstruction.
Once you have placed your tile and there are no obstructions detected, your robotic opponent will take its turn, picking up one of its tiles and placing it down on the board. This system uses inverse kinematics to find out how to move the joints of the robot so it can move to the right location to pick up the tile. We use James Poon's closed-form solution for this, which involves first rotating the base to face the desired point, then solving for the positions of the second and third joints using trigonometry. The system uses line-plane intersection to ensure the robot doesn't collide with any obstacles. When calculating the path from one point to another, the path is checked for any collisions. If there is a collision, the robot will try to avoid it by going up and around the obstacle.
Additional safety features included are simulated image stop and light curtain. When the e-stop is pressed, the robot will immediately halt and only resume when the e-stop is released and the resume button is pressed. The light curtain functions similarly, simulating an input from a real light curtain. When the light curtain is no longer broken, the resume button can be pressed to resume operation. Using the jog panel on the GUI, the user can jog the end effector of the robot in Cartesian coordinates, controlling the position of its end effector on the X, Y, and Z axis. Individual joints of the robot can also be controlled using the Teach panel, including activating and deactivating the robot's suction cup.
Some improvements that could be added to the system are a mount for the camera to fix it into a consistent position, and a more advanced feature recognition algorithm to localize the board and tiles, so the starting positions don't need to be fixed. Our modeled safety features, including the physical e-stop and light curtain, could be added into the real robot's workspace. In addition to this, an RGBD camera could be used instead of a webcam to better detect obstructions. Thanks for watching our video about Tic-Tac-Toe Bot.